Hello everyone, this is Rui PCB, your trusted PCB partner. Today we're going to design a single-sided PCB with through-hole components. We've already covered a lot of knowledge about single-sided boards before, so today we'll actually draw one. This board is the LED terminal driver board that we introduced earlier. So before we start drawing the board, we need to place the components first. I've already arranged them here. What should we pay attention to when placing the components? The main thing is to align the interfaces. For example, look at this 5V here, and this is also 5V, so I need to place the component in such a way that the 5V lines up with the 5V, and then the ABCD here matches the ABCD over there. That way, when I do the wiring later, I won't have to route around unnecessarily. That's one aspect. Alright, that's not finalized yet. You simply cannot place it like this. If you arrange it in this particular way, you can clearly see from the net connections that it will require a significant number of detours, which could lead to situations where the routing simply cannot be completed. So when placing these components, you need to pay attention, click's tongue, to keep the wires that need to be connected as much as possible on the same side. For example, here as well, we notice that most of the pins on the right side are connected to this LED, so I place them next to each other, which will reduce the number of connections I need to make later. As for the wires on this side, most of them need to connect to these 4 pins, so I orient it in that direction. And then, for this resistor, I also placed it with a bit of a gap, not side by side. The advantage of placing them side by side is that when I draw the wires later, I can run them directly underneath. If I place them side by side, then each wire would have to go around, which would cause some trouble and might even make the layout impossible. So the difficulty with single-sided board wiring lies right here. From the very beginning, when you're placing the components, you have to consider how the wires will be routed and how to position the components so that the wiring can actually be completed. Let's do a simple layout for this. First, I'll connect the 5V line. These 4 are all 5V, so I'll just connect all the 5V lines together and that will be done. There's also a 5V connection over here, but we'll leave that for now. Since there's only one power line, we'll handle it at the end. If you connect the power line first, it might block the path and make it harder for other wires to go through, so we'll lay out the signal wires first and connect the power line at the end. Now let's look at A. We see that it needs to be connected here, but there are also 2 wires that need to go upwards. If we connect A first, those 2 wires won't be able to go up. So let's not connect A for now. We'll wait a bit and connect those other wires first. You see, there's no problem with this wire going upwards, so let's connect it. As for these 2 particular wires, they are almost perfectly parallel to each other, so we will proceed to meticulously draw these 2 wires first. Then, carefully looking at wire D, hey, it's also a direct and straightforward connection. After completely finishing the routing of this specific wire, we can now thoughtfully consider how to effectively route this next wire, taking into account all the necessary considerations. So we have 2 options. One is to go around from above, and the other is to go around from below. I choose to go around from below. Alright, since this pin is at the bottom, I'll route it from below like this. So you see, if you had drawn this wire like this from the very beginning, none of these 3 wires would be able to pass through. So I need to first draw the 3 wires that look easier to route, and in the end, only this one wire will need to take a longer path. And on this side, it's the same. We observe these nets, and then, hey, this net is directly aligned. So for these direct connections, I'll draw them first. Like these 2, they're also directly connected. The rest are the ones that need to be routed around, so we need to think about how to do that. So for this wire, hey, it's very simple. I can just route it around from this side. Now, there are 2 more wires. The positions of these 2 are such that both are at the bottom, so routing them both from the bottom won't cause any issues. It's very easy to route them this way. These 2 particular wires are indeed very easy to carefully route around and manage, making the process quite straightforward. And then for the QA wire, we can choose to route it from above or from below. If we route it from above, look, there's the 5V here, and it's connected like this. If we route it this way, it will enclose the 5V, which would require us to use a jumper for this wire. So, the optimal choice is to route it from below, because routing it from below means it runs parallel to these 2 existing wires, and they won't interfere with any other traces. Now let me take another look at the wires. The signal lines are basically all routed. As for the ground line, I usually prefer to use copper pour to connect the ground, so I won't specifically draw the ground line. Now let me add the 5V line. After adding the 5V line, let's take a look. We only need to connect these 2 points, and there's just enough space above to route it through, so the 5V line is now connected. Then we can take a quick look. Basically, everything is already connected. We can also check it. I usually like to use DRC to check. What is the purpose of the DRC check? It's to confirm which lines besides the ground are not connected. We mainly look at the unconnected section. As we can see, all the unconnected lines are GND, so I don't need to worry. I can just use copper pour for that. If we find that something is still not connected, then we need to locate that trace. As for the copper pour, I'll keep it simple this time to save time and won't outline it in detail. Then press D to apply the copper pour. With this, all the traces are now connected. We can no longer see any lines that need to be connected. We can also run the DRC check again. See, now the number of errors is 0, which means the routing has been successfully completed. So, when it truly comes to the intricate process of single-sided PCB routing, there are indeed quite a substantial number of important things to carefully consider and meticulously take into account. First, the component layout. You need to maximize the routability when arranging components. Then, when routing, you also have to think carefully. Don't route a trace in a way that will block other traces. If a trace would interfere with more connections, you should abandon that route or find an alternative path that doesn't cause issues. You can't just route traces arbitrarily. These are the main methods for single-sided PCB routing. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you, everyone.